Dear students, welcome to the problem solving session on triple integrals part 2. In the first part, we see the basics on triple integrals and then we have evaluated few problems with all the limits are constants. And at the end, we have evaluated a problem with variable limit. Continuation of this, in this session, we are going to solve two more problems for more clarity. Evaluate integral 0 to log 2, integral 0 to x, integral 0 to x plus y, e power x plus y plus z, dz, dy, dx. As usual, let us take the problem as capital I. Now we are going to integrate this. First I want to integrate with respect to z and I would check my limits are in terms of x and y. So this is correct. Whenever I integrate with respect to z, all the other variables are going to be constant. So e power x plus y plus z, I'm going to rewrite this as e power x plus y into e power z because I can evaluate e power z alone. E power x plus y is constant with respect to z. And we know that integral e power ax dx is going to be e power ax by a plus c. So e power z integration is simply e power z. I'm going to substitute the upper and lower limit. And we know e power 0 is going to be 1. So when I multiply this e power x inside, we get e power 2 into x plus y minus e power x plus y dy dx. So now we have to integrate as usual. So integrating e power 2 into x plus y, we get e power 2 into x plus y divided by 2 into x plus y differentiation partially with respect to y is going to be 1 minus e power x plus y divided by 1. The limits are 0 to x dx. Before substituting the limits, it is better to simplify the content. Let us take LCM so that it is easy for us to substitute the limit at the end. So e power 2 into x plus y minus 2 times e power x plus y whole divided by 2, 0 to x dx. And we can push this 2 in the denominator outside the integral. Now we can substitute the upper and lower limit. So 1 by 2 integral 0 to log 2. When I substitute the upper limit, we get e power 2 into x plus x, that is 2 into 2x minus 2 times e power x plus x, that is 2x. When we substitute the lower limit, y equal to 0, we get e power 2x minus 2 times e power x. We have to simplify this further. Integral 0 to log 2 e power 4x minus 2 times e power 2x minus e power 2x minus into minus plus. So 2 e power x dx. Now we can club this 2 and we can write like this. Next we can easily integrate this 1 by 2 e power 4x integration is e power 4x by 4 minus 3 times e power 2x by 2 plus 2 e power x. The limits are 0 to log 2. Now we should be very careful while we substitute the limits. In the first video, we see the integration basics. We have to recall the formula e power b into log a or e power log a into b, it is equal to a power b. Therefore, when I substitute this log 2 here, we get e power 4 into log 2. It is 2 power 4. 2 power 4 is 16. In the similar way, when I substitute the limit here, we get e power 2 into log 2, that is 2 power 2, 4. And finally, when you substitute here, we get simply e power log 2, that is 2 power 1, simply 2. And when we substitute the lower limits, e power 0 is 1. So keeping this data in mind, we can simplify the previous step. So 1 by 2. When I substitute the upper limit, we get e power 4 into log 2 by 4 minus 3 times e power 2 into log 2 divided by 2 plus 2 times e power log 2. When we go for the lower limit, it is very easy. We have 1 by 4 minus 3 by 2 plus 2. Now substituting the values, we get 16 by 4 minus 3 into 4 by 2 plus 2 into 2. This part, for further simplification, I am just multiplying and dividing by 2. We get 1 by 4 minus 6 by 4 plus 2. Now cancelling and simplifying the terms, we will get the answer 4 minus 6 plus 4. Here, when you take LCM, we get minus 5 by 4 plus 2. So 1 by 2, 8 minus 6 is 2. When I multiply the minus inside, we get plus 5 by 4 minus 2. So 2 get cancelled. So my final solution I is 1 by 2 into 5 by 4. That is going to be 5 by 8. Hope you understand, students. You can see the typed version. Now let us solve one more problem in this kind. As usual, let us take capital I as my given question. Now the inner integral is dy. I'll check the limits. My limits are in terms of x and z, so it is going to be correct. Now integrating dy, it's simply y. Next we have to substitute the upper and lower limit. So lower limit is 0 and upper limit is square root of 4z minus x square. We get like this. Next we are going to integrate with respect to x, and my limits are in terms of z, so it is correct. Now the question comes how to integrate this term. By seeing the term, hope you easily remember the basic formula: integral square root of a square minus x square dx. In the first video, we see the formulas on integration. Let us recollect it. Integral square root of a square minus x square dx is equal to x by 2 square root of a square minus x square plus a square by 2 sine inverse of x by a plus c. Here a is constant. So using this formula, we are going to crack the problem. But my problem is 4z minus x square. Here we have a square. So a square is 4z. A is 2 root z. So if you remember this, we can easily crack the problem. So integral 2 root z whole square minus x square dx is equal to x by 2 4z minus x square plus 4z by 2 sine inverse of x by a is 2 root z. Therefore, integrating this term, we get like this. My upper limit is 2 into root z, lower limit is 0. So when I substitute the lower limit, my first term will become 0. 0 into anything is 0. Similarly, so when I substitute the upper limit, we get 4z minus 2 root z whole square is 4z minus 4z. It is going to be 0. So both the cases it is 0. So I can neglect this term, and we are going to substitute the limit for the second term. So I can cancel this 2. So 2 into z. When I substitute the upper limit, 2 root z cancel with 2 root z. We get sine inverse of 1. When I substitute the lower limit, it becomes 0. And we know that sine inverse of 1 is pi by 2, 90 degree. And sine inverse of 0 is 0. Therefore, integral 0 to 4, 2z, pi by 2 minus 0 into dz. So I can cancel this 2 and we get integral 0 to 4 pi z dz. Easily we can integrate this by taking the pi outside. Z integration is z square divided by 2. The limits are 0 to 4. Simplifying this, we get 4 square by 2. Lower limit is 0. So 16 by 2, 8. My answer is 8 pi. Therefore, the solution for this problem is 8 pi. You can see the typed version. Hope you understand, students.
Thank you for watching. We hope you found this video helpful. Stay tuned for more and keep up the great work. Subscribe to our channel and see you in the next video. Bye bye.